In section 3.5, we changed gears just a little bit compared to the previous 4 sections in this chapter, and we're going to look at ratios and proportions. So first of all, what are those? Well, a ratio is a comparison of two quantities by division. And because we're going to be dividing, we need to stipulate that b is not equal to 0. Then we have 3 different representations for a ratio. We can write it in words, a to b, or use a colon, a to b, or write it as a fraction, a to b, because remember this represents division. And here you can see why b cannot be 0, because we cannot divide by 0. And no matter how we write it, we still read it as the ratio of a to b. And we want these ratios in simplest form. Then a proportion is an equation that states that 2 ratios are equivalent. So a over b is equal to c over d represents a proportion. And remember, we cannot have 0 in the denominator, so b must not be 0 and d must not be 0. So let's look at some examples here. So in the first case, we're going to write a couple of ratios. We have a football team has 10 wins and 4 losses. Find the ratio of wins to losses. So if we look at wins to losses, this will be equal to 10 wins over 4 losses, but then we need to simplify that because 2 will go into both of these, and we end up with 5 over 2. So for every 2 games they lose, they win 5 games. Then find the ratio of wins to all games. So we're looking at wins over the total number of games. So this is going to be equal to 10 wins over, they had 10 wins plus 4 losses. So that gives us a ratio of 10 to 14, and again we can simplify this, divide each by 2, and we get 5 over 7. So in other words, they win 5 out of every 7 games. And notice here that if you divide the numerator by 2, you end up with 5. Divide the denominator by 2, you end up with 7. So in other words, if you divide both the numerator and denominator by the same number, you end up with an equivalent ratio. Likewise, if you multiply the numerator and denominator by the same number, you'll get an equivalent ratio. And we're going to use that idea in solving proportions. So this is one way to do it. You've probably seen other ways to do it, and we'll look at another way to approach these problems in the next section. But for now, one way to look at this is how do you get from one numerator to the other, and how do you get from one denominator to the other, and it will be the same method. So we're trying to get from the second ratio back to the first to solve for that unknown x. So look at the denominator where you have a value in both ratios. How do you get from 8 to 2? Well, you would have to divide by 4. And that means to go from 3 to x, we're also going to divide by 4. So x is equal to 3 over 4. 3 divided by 4. Okay, so now check your solution. So we're going to look at 3/4 over 2, and we want to know, does that equal 3 over 8? Remember, one way to divide here, when you have a fraction divided by 2, we can multiply by the reciprocal. And the reciprocal of 2 is 1 over 2, and we want to know, does that equal 3/8? And of course, when you multiply 3/4 by 1/2, you will get 3 over 8, which does equal 3 over 8. Our solution checks. Solve the proportion 8 over 1 equals u over 5 and check your solution. So now we're going from the first ratio to the second. In order to get from 1 to 5, we have to multiply by 5. So we're either multiplying or dividing, not adding or subtracting. And then to get from 8 to u, we need to multiply by 5. So u is going to be equal to 8 times 5, which is 40. then we can check our solution. Does 8 over 1 equal 40 over 5? And in this case, we can go ahead and do a division. 8 divided by 1 is 8. 40 divided by 5 is 8. So that checks. Number 4, solve the proportion 4 over 10 equals q over 12. Check your solution. So here's a case, this isn't quite as convenient as we would like, but we can still use the same approach. So first of all, we can simplify 4 over 10 to 2 over 5 is equal to q over 12. And then how do we get from 5 to 12? We would have to multiply by 12 over 5. So if you take 5 times 12 over 5, you'll get 12. So we're going to do the same thing going from 2 to q, multiply by 12 over 5. So q is equal to 2 times 12 over 5. If you want, you can write that 2 as 2 over 1. So 2 times 12 will give us 24, and 1 times 5 will give us 5. And there's no simplifying that we can do there, so we're done. Then we can check our answer. Does 4 over 10 equal 24 over 5 all over 12? Well, 24 over 5 all over 12 is equal to 24 over 5 times, and then instead of 12, 1 over 12. And here we can do some simplifying, because 12 goes into 12 once, 12 goes into 24 twice, and we get 2/5. So then we have 4 over 10. And does that equal 2 over 5? Yes, indeed it does, because we can simplify that 4 over 10 just like we did at the beginning. 2 over 5 is equal to 2 over 5, and our solution checks. You solve the proportion r over 12 equals 3 over 4 and check your solution. So we're trying to work from the second ratio back to the first. So going from 4 to 12, we have to multiply by 3, which means going from 3 to r, we also multiply by 3. So r is going to be 3 times 3, or in other words, r equals 9. And then to check that, we look at does 9 over 12, so we substitute our solution back in place of the variable. Does that equal 3 over 4? 9 over 12 will simplify. Divide each by 3 to get 3/4, and yes, it works. Set up a proportion for the following problem. If 2 cups of corn kernels can make 9 quarts of popcorn, how many quarts of popcorn can be made from 5 cups of corn kernels? And notice here, we're not actually asked to solve the problem, we're just asked to set up a proportion for the following problem. So here, match your units. So we have 2 cups of corn kernels will produce or give us 9 quarts. 9 quarts of popcorn. Okay, so then our other ratio needs to have the same unit set up. So we have how many quarts of popcorn. So how many means we're looking for x. That has to go on the bottom because that's where our quarts of popcorn will go. So x quarts of popcorn. And then the cups of corn have to go on top. So the 5 cups of corn kernels will go on top. Okay, so cups of corn to quarts of popcorn, cups of corn to quarts of popcorn. So we have our setup. We're not asked to solve it in this case, so we're done. Number 7, a certain train can travel 200 meters in 3 seconds. How long will it take that train to travel 1 kilometer? So set up our first ratio, the one that we know. 200 meters takes 3 seconds. And this is going to be equal to, and now look at our units. We have distance over time. We want to know how long will it take. So that's where x is, or you could even use t for time, but we know it needs to go on the bottom because that's where time goes. And then our distance is 1 kilometer. Now we need to match up units. And notice that, or recall that 1 kilometer is equal to 1,000 meters. So we can rewrite this as 200 meters over 3 seconds is equal to 1,000 meters over x. And now we're trying to work from the first ratio to the second. So going from 200 meters to 1,000 meters, we need to multiply by 5. And that means going from 3 seconds to x, we have to multiply by 5. So x is equal to 3 seconds times 5, which is 15 seconds. All right, number 8. Write the sentence as a proportion and then solve the proportion. So 4 is to 9. So 4 is to 9 as, that's where our equal sign goes, x is to 27. So x is to 27. We're trying to work from our first ratio to our second. So going from 9 to 27, we multiply by 3. That means going from 4 to x, we also multiply by 3. So x is going to be equal to 4 times 3, or in other words, x is equal to 12. And if you were to write 12 over 27, notice that that simplifies when you divide each by 3 to 4 over 9. Mary's car can travel 200 miles on 5 gallons of gas. How far can it travel on 12 gallons of gas? So we set up 200 miles over 5 gallons of gas. And then we have to keep the same units where we're looking at distance over gallons of gas. How far can it travel? So we're looking for the distance. We know the gallons of gas, 12 gallons. Okay, so again, we're trying to go from the first ratio to the second, and we had something similar to this before. To get from 5 to 12, we're going to multiply by 12 fifths. So 5 times 12 fifths will give us 12. That means we have to also multiply 200 times 12 fifths. So x is equal to 200 miles times 12 over 5. If you want, you can write this as over 1. Notice that 5 will go into 200. That helps us. 5 goes into 5 once. 5 goes into 200 40 times. So then we end up with 40 times 12 over 1. Or in other words, 480 miles. Okay, and you can stop and think 12 compared to 5 is a little more than twice 5, so we should be able to drive a little more than twice the distance. So 480 makes sense. Okay, John can jog 2.6 miles in 20 minutes. At that same pace, how far could he jog in 1 hour? So we need to match up our units. So we can look at 2.6 miles over 20 minutes is how far in 1 hour is equal to 60 minutes. So now we're looking at multiplying by 3. Whoops, let's make that a 3. Which means we have to also multiply by 3 here. So x is equal to 2.6 times 3, and that's in miles. And we're going to get 7.8 miles out of that. Okay, so again, remember, this is just one way of solving proportions, but we want you to get working on the idea of ratios and proportions. Be careful with matching up your units. Next section we'll look at a different way to solve these that is probably more familiar with what you've seen before. Good luck.